So I get good camera angles and all of that. Okay, good. So today we're going to work on section 1.4. Section 1.4, thank you, on solving quadratics. And as I was just saying here, you have all solved quadratics before. So this is nothing new. I'm not going to spend a whole lot of time going over things that you should already know. The one good thing I would say, your book in section 1.4 has a whole lot of practice problems for you to do. If you go online, when you look online, you'll see all the problems I have recommended. They're all the practice problems. So if there's some aspect of solving a quadratic you're not sure about, that you're not entirely clear on, just look at all the practice problems and do them, and kind of get that skill back. Start off with maybe this. As far as a quadratic goes, say we have something like this. X squared plus x minus 6. As far as it goes, that's a quadratic. It's in standard form, correct? We all know what standard form for a quadratic is? Ax squared plus bx plus c. A, b, and c are all just the coefficients. In this case, 1, 1, and negative 6. And we're good. The first thing you learn when you learn quadratics is factoring, correct? And you generally start with something like this, a quadratic in standard form where the leading coefficient is 1. And again, I am not going to teach you how to factor. That's something you should already know how to do. So really quickly, let's see. It factors to two terms. That's x squared. Leading coefficient is 1, so that's an x and that's an x. And then if you remember your rules for factoring, which I'm sure you all do, you need two numbers whose product is negative 6, whose sum is that coefficient, which is 1. What two numbers multiply to negative 6 with a coefficient of 1?
Positive 3, negative 2.
Positive 3, negative 2. 3 times negative 2 is negative 6. 3 minus 2 is positive 1. There you go. So you get x plus 3 and x minus 2. And all of you can do this, right? Good. Just really quick, x squared plus 13x plus 30. Yes, that's why I wrote it on the board. I wanted factored, yes. Leading coefficient of 1 again, so it's going to be x and x. Two numbers whose product is 30, whose sum is 13. 10 and 3, sure. So you get x plus 10, x plus 3. How about x squared plus 13x minus 30? Leading coefficient of 1, so you get the x and the x again. 15 times negative 2 is negative 30. 15 minus 2 is 13. There we go. X plus 15, x minus 2. We could spend all day doing this. All of you know how to factor, right? All of you are like me, and as soon as you learned this, in whatever grade it is you actually learn it, I can't remember at this point, you all said, wow, that's really cool, and you went home and did it hundreds and hundreds of times and spent every spare minute factoring whatever quadratic you saw just because it was fun, right? Your people lead boring childhoods. This is what you should do for fun. Sit around doing math. On the plus side, it means I can actually factor reasonably well because I spent so much time as a teenager doing it. Ultimately, when you originally learned this, a lot of times there are different ways to solve quadratics, and you will kind of have a test where it says, part 1, solve these by factoring. Part 2, solve these by completing the square, or solve these by the square root method. And you have to show each different method of solving a quadratic, correct? All things being equal, I could care less which method you use to solve a quadratic, as long as you can solve a quadratic. Factoring makes things faster and easier, which is a good thing, more efficient from a mathematical perspective, which we like. But if you don't know how to factor, there are other ways to solve the problem. So you should know this, and it can be helpful and make things go quicker. If you know, whatever, okay? But like I said, there are practice problems in your book. So if you want to review your factoring to brush up on it, I don't think I gave you many of them for homework to turn in, but there's a whole bunch of them you can do just for practice. Let's see. Well, before we even move on to other methods of solving this is just factoring, but suppose we actually wanted to solve a quadratic equation. So we'll get rid of that, get rid of all those. back to the x squared plus x minus 6. You want to solve it? So sure, the first thing you do is factor it. X plus 3x minus 2. Generally, when you have a quadratic, it's then equal to 0. So now we factor it, and this is equal to 0. Now what do I do?
You make both of them you make equation of both of them?
You make an equation out of both of them. Why?
Because they equal to 0 and we want to...
And so you can just make them 0?
Yeah.
Yes? Why?
Because they equal to 0.
They have to be 0?
They equal to 0.
They equal to 0? I care more about the why than about the answer. Why, when you have a quadratic, do you make sure it's set equal to 0, and then we try to factor it? Why is that a useful thing?
It can be graphed.
That can be graphed. You actually will graph that just like that in about maybe a couple of weeks or something. I don't know, whenever we get to it. I would actually argue this is maybe somewhat harder to graph, at least for me. I prefer to graph that one. Let's see. What is 5 times 4? 20. Good. What is 6 times 3? That's early in the morning, but that's 18. What is 3 times 0?
0.
0. Why?
Because anything times 0 is 0.
Okay. What is 8b equals 0? What is b?
0.
Why?
Because it has to equal 0 anything times.
Because all of you can do algebra, and if you want to get the b by itself, you divide by 8 on both sides. Those cancel, and you get b equals 0. Alternatively, there is actually a rule in math that says if you multiply two things together and you get 0, one of them has to be 0. Because the only way you multiply and get 0 is if something is 0. Yes? It's actually called the cancellation property or the zero product property. I don't really care about the terminology. But essentially it says if a times b equals 0, then a equals 0 or b equals 0. That's important because it actually helps us solve these quadratics, correct? First step to a quadratic set equal to 0, factor it if possible. Why? Because then you have this thing, call it a, times this thing, call it b. A times b equals 0, which then allows you to break it up as two factors and solve. Because either this, a, which is x plus 3, has to equal 0, or this one, b, which is x minus 2, has to equal 0. And now those are easy to solve. This one gives me x equals negative 3. This one gives me x equals 2. And yes, I am aware that you've probably all done this thing, and you know to just set them equal to 0, and you're done. But again, I care more about the why and why things work, not just using some rule that somebody told you and you do it because somebody told you to do it. You should know why you're doing it. That's why it works. Fundamental, really cool property in math. Okay? Any questions on this? Okay then. As far as it goes, well, for factoring, there are different tricks for factoring. Does everybody remember factoring a perfect square? There's a rule for it, if you remember the rule. Does everybody remember factoring a difference of squares? Some of those things will pop up throughout the semester. If you don't remember them, again, you can practice your factoring. Ultimately, it doesn't really matter. There are other ways to solve quadratics, right? What's another way to solve a quadratic? Everybody say the quadratic formula. Everybody loves the quadratic formula, right? Yeah. So we are going to go over the quadratic formula right now. One thing I will point out, both to you in the classroom and you especially online, because this video is going to end up on YouTube. The quadratic formula you should all know and you should all have memorized. On an exam, you're going to need it if you don't know how to factor, and some quadratics you can't solve by factoring. You have to use a quadratic formula. I don't care how you memorize it, you have to memorize it. You can actually make a song out of it, correct? Is it a safe assumption that at some point one of your teachers sang it to you? Okay, I am never going to do that. More to the point, since this is going to be on YouTube, there is no way I will ever post a video of myself singing anything on YouTube, so that's not happening. If you want to hear somebody sing it to you, go to your high school teacher, or if you're here on campus, go to Mr. Price. He loves singing the song. But just for my benefit, assuming you have a quadratic in standard form, ax squared plus bx plus c equal to 0, always set our quadratics to 0, quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And all of you know that this a, this b, and that c refer to the a, the b, and the c up here in your equation, right? Good. Then solve this one. Solve it using the quadratic formula. And while they solve that here in the classroom, I'm going to turn the video off because the 15 minutes are almost up, and we'll pick that up with the next section of this wonderful lecture. You guys doing this on the video can work on it and then turn the next section on to see your answer.